Hello and welcome to this video from Maidenhead Bridge. In this video we are going to show how to deploy a pair of cloud security connector CSC PriCPA on Azure on high availability. In this demonstration we will have to install these two connectors, and also we are going to show how to connect to this data center in United Kingdom. This is in Azure East US, and also we have another connector in AWS East US. And we will run a high performance test between these devices. Before to start with this demonstration, let's do a quick review about the Cloud Security Connector. The Cloud Security Connector PriCPA, all this functionality, the PriCPA, this is on a standalone device we're going to see today, but remember this functionality PriCPA is also available on the connector for Azure and Netscope. What is the PriCPA functionality? Well, it works like a service broker cloud. You can cut in half here the connector and say half of the connector is serving the cloud functionalities, then is the node in the cloud node, and the other half is serving the local node instance for zero trust and applying all policies. With this approach, uh, we have several benefits. First of all, we don't need a broker in the middle. You don't need a cloud infrastructure here. It's just internet. The other big benefit is crypto key routing, encryption packet per packet technology. Then it's not needed to create uh, tunnels in advance. Then it can scale very well. Let's do a quick review. 80% savings comparing with other solutions, VPN gateways, using VPN gateways from the cloud or service broker cloud, because there is no infrastructure to maintain. It's also to put the connector and to pay per CPU. Any to any communications, there is no restriction. You can connect here to here to here to here as you wish. All traffic is encrypted. All traffic in transit is encrypted. All protocols are supported. There is no limitation in the type of protocol supported. It's scalable. Again, you can do multiple sites, and also you can create multiple PriCPA clouds if you want. It is zero trust, 100%. If I create a role, the saying this machine will talk with this instance, this machine will not be able to talk with the instance at the same subnet. Networking as a code, we will see in this demonstration how easy it is to configure your PriCPA cloud and your policies using a single JSON file. Everything is DevOps automated. We are going to show on the demonstration from the deployment side how the node can be created automatically at the moment of the deployment, and how to refresh the policies after. Two-step configuration on board the node on the PriCPA and deploy policies. We are going to see this on the demonstration. Traffic visibility end-to-end, 100%. If this machine access to this server, on this server, you will be able to see the logs of the source IP of everything from this client. It's not hidden behind the NAT. Traffic logs, we're going to see the traffic logs and the system logs too. It's a technology that blocks lateral movement. Yes, 100%. If this machine is talking with this instant, it's not able to see the other instant at all. And high performance, and we are seeing the demonstration that each connector supports 1 gig. That is almost the double or 4 times what the Service Cloud connector can do. Then it's very, very high performance. Let's move on. Let's go to the demonstration now. The objective of this demonstration is to install, to onboard the nodes on the PriCPA cloud, and to create a policy allowing this allowing access to these high performance servers and these nodes. And after we will do a performance test to this server to show the performance. It's very simple. The only prerequisite you need to have is two subnets on Azure, the public and private. The connector is a firewall. The connector isolates your external traffic of the internal world. That's the reason we need two subnets. And also the connector manage here all the security groups. There is a lot of things the connector does automatically. They manage the security groups. Each time you add a node, the security group will be created automatically by the connector. You don't need to maintain anything here or to keep it open to the entire world. Here you have that this connector will be allowed to talk with the public IPs of your site only. It's not exposed to the internet. In high availability, the connector has the intelligence. There is, as you can see, there is here an IP, public IP we call floating public IP. If in the case if this connector is active, this IP will be attached to this connector. And from the internal side, this connector will also manage all your internal routes and will put its own gateway as gateway of the route, internal routes. Then the traffic will flow via here and the public IP will be here. If this goes down, the other connector automatically will pick up the IP, will set up the IP in its own interface, and we will move all route via the gateway here. Then it's absolutely self-sufficient, and you don't need to pay load balancers or to nothing. You don't need anything extra to achieve high availability with the Cloud Security Connector PriCPA. Let's move on. Let's start. Let me take. I have a little script. We were trying to do an installation with or without Bastion host. We can select the way we want to do. The first thing we need to check is to review the configuration, user data file, and the parameters that we are going to pass during the installation. Then I will move here. And this is my config user data file. There is some parameters on the top standard. And here what we're going to do is to pass the activation code and activation ID and region of the AWS SCCM agent. What we're going to do here is during the deployment, I'm registering these two connectors to this system manager. AWS System Manager is our preferred method of communication. If you are not familiar, what now is called System Manager Fleet Manager. You can register any Linux or Windows machine with Fleet Manager, and you can run commands on the machines. System Manager is fantastic and it's free. Then you can open a free account on AWS and can use this for free. AWS allows you to manage up to 1,000 nodes per region. Then you have multiple regions, but in this case are attached to London. Again, use AWS System Manager for this purpose. There are more tools that you can use. For example, you can use Ansible, Rundeck, or Azure CLI commands to manage the connectors. But in general, because you will have connectors in different clouds and on-prem, we recommend to use AWS System Manager, but you can use any change management tool you want. In terms of deployment, you can use Terraform or Azure Resource Manager. In this demonstration, we are going to use Azure Resource Manager. Then going back to our config user data file, we're going to pass the keys for the registration of each VM on AWS ACCM agent. We are setting this DNS just for testing purpose. We are going to enable traffic logs, and also we are setting our syslog. And here we are passing the PriCPA values that we need for the initial configuration, for the local configuration of the connector. Remember, it's two steps, local configuration and also after the peers configuration. Then for the local configuration, we need to tell the connector know the name, location, description, public port, UDP is going to use. By default, we use 51820. On the private side IP, we need to pass the private IP of this connector. And let's back to review what is this private IP. When you design the PriCPA cloud, you need to assign a subnet to your PriCPA cloud. It's very important. This subnet is unique for your PriCPA cloud. And each connector will have one IP of this subnet. Okay, this is fundamental. Then our first task is to assign a private IP. I'm assigning the 25 to this connector. Okay. Also, the other value we need to have to pay attention is the public IP of each connector. In the case of the cloud, you don't need to be worried about because the connector will read the public IP via API and will do the setting. When you are on your own firewall, well, you need to select manually one IP. And the other value we need to be, we need to tell the connector after on peers file is the subnets behind. But for the moment, for this step, a step of design is private cloud has its own subnet. I'm assigning an IP, private IP of this subnet to this connector. Persistent keep alive equal no. When you are on cloud, persistent keep alive is not needed. Sometimes when you are on a firewall or in virtual machine environments like VMware, you will need to enable it. Peer JSON files, this is where the peer JSON file is stored and is on AWS bucket. And the peer JSON file, I have this file here, and we are going to explain the values here, what it means, and what we need, how we need to set up this. But this is very important. This is your infrastructure as a code, and we are going to view in detail what happened here. And this file, this one file where you have each node, the network behind the node, and the apps behind the node. We are passing this URL, then the connector will be able to go to this bucket and will download the peers file and will do automatically the configuration. Okay. Other values that we need to tell the connectors, we need to tell the connectors on PriCPA, the remote management network, especially when you are on high availability, you need to do this because you need to tell the connector that the management networks are not local and not here behind the connector. The management networks are in a remote place. Then we need to specify. In my case, I have 3 management networks and I pass these values to the connector. Other values that we're going to pass here are the SSH restrictions. Then the connector, you can do SSH to the connector only from the management networks and this local IP. And last, the connector has the ability to has already created a CSC CLI user, and you can enable at the moment of deployment, and you can pass the SSH key. The reason of this is when you use, for example, you use Ansible Rundeck, or any change management system you want to use, this allow you to SSH terminal console and run the commands. Then it's very important the user CSC CLI when you want, or you want to the access to the terminal of the connector. That is allowed. By default, the standard user of the connector is the user CSC admin, and you can enable terminal access with CSC CLI. Okay, we are almost ready to start. Then let me show you here the marketplace. This is all the offers on Maidenhead Bridge. We have the CSC MOOCs for SaaScaler with PriCPA, Model 1, 2, and 3. You can use this. And there are also specific offers. But the truth is we have for Zscaler with PriCPA and also for Netscope with PriCPA. All of them are compatible in PriCPA. You can mix anyone. And the model we are going to show today is this CSC PriCPA that is a standalone product. It's only for private traffic and it's not for Netscope or Zscaler. Then if I go getting out, I think I will deploy let's do availability zones. Okay. And this is the console. You can select here availability zones. Here is an explanation of what is PriCPA. PriCPA is a cloud-native solution for one encrypted communication that allows site to site-to-cloud, blah, blah, blah. The plans, all the ability, all the information here. The plans are, in all cases, is 10 cents per hour per core, and one core is required. Maybe if you have several CSCs, you need more CPU on core, but for 1 gig, and we recommend to start with one core. Then it's very cheap device and nothing else need to be paid. Then I will go to create a CSC PriCPA. I need to select my resource group. I will deploy two on high availability, Zone 1, Zone 2, and the name is demo. Let me take the name from here. Okay. Demo CSC PriCPH. I will use password. Okay. Now next. That's fine. This is standard VNS. You can change your site. You can choose the best virtual machine for you. And I will use a standard or premium. That's fine for storage. The next selection is the subnet external and internal. Then select, this is external subnet and my internal subnet. Okay, next. Paste here, they configure the data.json file. Then I will come here. And next. It's a review if you have availability of IPs and all the stuff. And create. And what is this deployment is creating the public IPs, the network security groups, and the virtual machines. We need to wait. It's very, very fast process. Well, depending the region of Azure on the day. But in general, it's very, very, very fast, the deployment. Okay, I will pause the video meanwhile we wait for this. Okay, no needed. Okay, we have the setup is complete. Now, if we, in our source group, if we search for demo CSC, we have the two virtual machines here. If I go to my virtual machines, I have these machines here. Well, the first thing now, if I go back to my script, I deploy this. I need to obtain the local configuration of each one. Okay, and also I need to add the local configuration to the JSON spear file and add the IPs to the S3 bucket. This is something we're going to do now, and to obtain the IPs, public IPs and private IPs for SSH. Then let me go here, networking, and this is the service IP. The service IP, I need to allow the service IP. The connector has two IPs. The service IP is for external communications, updates, all the stuff. And the PriCPA IP, that is the IP that's going to be used for PriCPA communications exclusively. Then I need this service IP because this IP will go to my bucket here, and on permissions, I need to allow this public IP. Okay. And also I need to add the other public IP of the other connector. And come here, networking service IP, this public IP. Okay, save changes. Good. The other thing I'm going to take in account is for this PriCPA1, I will go to networking and I will check my CSC gateway private IP. This is 224. Okay, and I will record here. HCI unit is fine. This is 4. This is to access to the connector after PriCPA is enabled. And the other one is this one. Internal IP gateway is the 5. 5. Edit. Number 5. And save. Okay. Well, now I have this housekeeping about the IPs. This is IP you need to SSH interface. Internal Ethernet 1, 5, and here the internal number 2. Okay. The other thing I need to do with this IP is to go to my internal route table, and there are 3 destinations here, private IPs, that these destinations initially I will send via my first connector. That is 4. Updating the route. Okay. Okay, and now this one. Okay, this route table, to do an overview here, is for these remote destinations. If I back here, what I'm saying is go to this 10.3 and these destinations via this connector. Okay. Then any internal communication to these destinations will go via the connector. Well, going back to my script, obtain local configuration via AWS. Then if I go to my Fleet Manager here, if I do a refresh, you can see we have the connector 1 here and the connector 2 here. Okay. This happening not by magic, this happened because we passed the keys on the configure the user data. Then what I will do is on this connector number 1, sorry, uh, yeah, number 1, I will run tools, execute run command. Uh, oh no, I will run shell script, and I will on the command parameters, I will do this. This can be done from here, from AWS. We're trying to not to use a Bastion host, but this can be also done on the instance. If you go to the instance here and you do a run command, run shell script, we can run the command here too. Okay, and also via Azure CLI, and you will get the private configuration. Let's do via AWS. We said use the AWS, then run shell script via AWS. And run. Okay. And now I have the output here, and I will do a copy. I will open a new text file and paste. Okay. As you can see here, now we have the local configuration of the connector. Some of the parameters are the parameters we pass here, the name, location, demo video, yeah. The public key of the connector, this need to be known by the entire cloud. The private key is inside and not accessible, of course. But the public key is distributed on the entire other connectors. This information need to be distributed. Public IP is going to use this 74.204. Then if we check here, what happened is on networking, the PriCPA IP 204. Okay, that was selected automatically by the connector, and the port is the port we provided here. Finally, the internal IP is the connector, and that's it. Then what we need to do is to copy this section, okay, of the local configuration and to go my PriCPA. Let me do proper things here. Up to public IP now. And to go to my PR.json file and to paste here. And save. Okay. What is the configuration? Then that's it. This is still I need to do. The next configuration, remember, we have always the local node information, then the networks behind the node. Going back here, remember the three IDs, IP, public IP and port, private IP and networks behind. Then we have the public IP, the private IP, and the networks behind. The network behind, in my case, is this VNET. That's it, period. Now I need to define the apps that I want to be accessed behind this connector. And I define the following. For the entire subnet, entire VNet, from the management networks, I will allow port 22 and 338, RDP and SSH. What I'm saying here I will allow the management network from here to access any machine on SSH and RDP. The other rule I created here, I say SNMP, enable SNP via management networks. Then from management networks to any destination of SNP. And the other is a test from Google. Then from this instance, we have another connector here in Google. It's a PriCPA on Google here. And what I am allowing is from this machine on Google to ping this machine on this VNET. Okay, that's it. This is the only that you need to do. In order to talk, in order this machine to talk with this machine, the rules are created behind on this connector. Okay, let's take a view of this. This is the connector on AWS, and I'm saying here that I'll allow SSH and RDP and SNP. High performance. I will allow from this machine, this subnet that is on the VNet 10.2, protocol TCP and port 5500. Okay. Then the rule that allows my machine on Azure to communicate with the machine on AWS is here. I'm saying the source IP can talk with this destination in these ports. Then the rule is applied here and is reflected on the other connector. This is important for organization. For organization, it's better to say I know my applications behind, and I know who need to access to these applications. Then the configuration is pretty simple. It's much simple. The only that you need to know, every time you deploy a connector, your subnets behind the connector, your apps on this site, and who will access this app. That's it. Okay, we have now the JSON file created. We are going to deploy on my bucket here. Okay, I put the permissions for the bucket. It's per source per IP. Then now let's go to object, upload object, add files. This is the next scope. That's fine. And upload. Okay, perfect. Now, the next step is to refresh the peers file to the entire cloud. And I'm refreshing the peers file in the entire cloud using AWS System Manager via one command. And every connector will pick up the bucket, will connect the bucket, and will download the peers file. I will create all the rules automatically. Then let's go to the here fleet manager again. In this case, let's do a quick filter. Pin status equal online. Select all nodes of this PriCPA cloud. Let me delete this node. This is not a PriCPA. And let me check if I have another one that is not PriCPA. Okay, this is all. I have several nodes here, and here is the demo and 1 and 2. Then node actions, execute run command, owned by me, and refresh private access peers URL. All these documents that you can upload to your console, AWS console, are available on our support site. It's a CloudFormation template that you can deploy and will create all these documents we have here. Refresh private access peers URL. All the instances are here, and run command. PriCPA is not implemented. No, I need to do manually here. And the She Cloud. What is happening now, each connector is creating all rules, is onboarding the new node, and all this. Let's wait to be successful, all of them. Okay. Now I'm going to check the results here on this connector, PriCPA H1. Oh, little detail, very important. I missed one point in my script. Let's say here, enable identity. Okay, the connector requires to set up properly the identity here in order to manage the Azure CLI. Then I will assign the identity first. You need to put on status on, and then you need to assign the roles. And the roles that are required are resource group. The resource group for the connector you need to be contribute. Okay. Next, on the resource group, you have your route tables. You need to be a contributor too, in order to change the internal route tables, this gateway, Netscope. And finally, you need to assign another of the resource group. What is your subnets? You need to assign the network contributor. Okay. This takes time to refresh, but the roles are here. Now let's go to the other machine, this one, and let's go and assign identity too. So role, again, we need to be a contributor of the role where the virtual machine is. We need to be where the route tables are. We need to be a contributor to. And on the security group, on the resource group where the networks, the subnets, are, in that case, we need to be network contributor, because this is used to change the external security groups of the connector. Okay, now I have in both done, the job done. Let's back to the resource manager. And if I check the other command probably fail it too, but if I check any, I don't know, any other connector, we expect this communication. Then I will go to my fleet manager here. I will select all, and I will select my two connectors only, these two. Okay, and I will do execute run command now, owner by me, and I will run the document refresh private access URLs. Do. Okay, this is the second one. We need to enable after. And now this one that we expect to have it ready now. Okay, this is what we expect. If I come here, what is happening, the JSON file, the peer JSON file, this one with all the information of all nodes in the in the in your private cloud is imported uh, successfully, and all the private app we created, some of them are not related to the node, and others were created or related to this node. The all peers were added, and finally the security groups were automatically created with the rules. Let me show you on the security group here of this machine one. This machine one, if I go to networking, you will see this security group that contains all the IP range that are other nodes in the private cloud, and also the outbound rules require. Then you are protected by security groups communicating your public IP and public IP, and no one IP is opened to the world. We are ready to go. Now we should have access to this virtual machine via PriCPA, via this connector. Then I have this access to this machine via backdoor. This would be a firewall. But if I go via PriCPA, I should have access now using PriCPA. Magic. Okay. Also, if I check my logs here, you can see now the connector is reporting the logs. This is the system logs talking about the rules and all the stuff that is was created. And the reason why this is happening is because during uh, the launch we provided the configuration for this. The other access we should have, if I'm not wrong, should have access to the connector via CSC admin. And the first screen you receive on the connector is please add this connector to the peer JSON file. And you did it? Yes, I did it. And if I'm not wrong, I should have access to the other connector too. Okay. This is the CPA2. Then what we achieve this configuration using the AWS System Manager is that we are deploying a pair of connectors without having a Bastion host behind directly using System Manager. Okay, now my task is the first connector is completely configured. I need to connect to configure the second one and to um, create a high availability. Let me check my script. Run command all nodes, SSH, well, I can SSH the internal and external, and configure HI and in both connectors. This is extremely simple. Then let's go to the connector one. The connector, the first is the second one say the PriCPA is not configured, and this is intentionally when you use configure user data, we are configuring the number one, not the number two, because we need some information. We need to pass the keys. Sorry, we need to pass the keys, the public key from the primary to the secondary because they use the same. But primary keys are created only in one. knowing both at the same time because the result will be different, then we need to configure now this PCPA on the second connector here. You can see it's PCPA is not configured, and then please use go to number 5 and configure local peer configuration. Very good. Then I will configure here, say 5. Here it's telling me use identity, remember to use identity, all the roles and stuff. And I will say 1, create or change private access local configuration. Now it's checking if the identity is assigned and will appear the prompt. Okay. Now the identity is confirmed. It's logging in on the API, all the stuff. And you have two options. One is manual configuration, another is token and JSON. We are going to do token and JSON because what we want to do is to copy the local configuration of the active on the passive. Then I will go here and I will go to 1, show configuration status, and I will do on the primary show local configuration. Then on the secondary, the only thing I need to do is using token and JSON. You will need the string of the token and the JSON file from the local configuration. Then the only thing I need to do is to come here, copy this, and come here. And copy and paste it. Then now the connector was picking up the values. What is the public IP? What is the subnet? All the stuff. Do you want to apply values? Yes. Good. My next step now is to configure high availability. Now I need also to refresh here the PriCPA peer JSON file, but I will do high availability first. Then on high availability configuration, I need to come here to configure high availability, and I will do manually the high availability. On high availability also you need to create this identity, the same identity I did. It tells you go to routes inside your route table and create the routes that you want to control. Remember, I have this route created already. I created this is my route table. At the moment, I want to control these 4 routes that are currently, there's refresh is not correct. Oops, I guess this one is under control of someone. No, it's 4. Okay, this is a little bug on the, now it's showing 4. Okay, this is a little bug on Azure that is not refreshing properly in Netscope sometimes. I want to control these 4 routes that belongs to this route table and a resource group. They have the routes here. This is the route table. This is the resource group. This is the name of the route. The 4 routes I want to control the Netscope via high availability. Then let's move on and let's do it. Let's back to here. I want to configure high availability. Yes. I will input manually here, but you can do by JSON file. Also, you can do remotely. Then route name, my first route name is this one. Okay, that belongs to the route table. Call it server route table. Oops. And the resource group is route tables. It's US. Okay, you want another? Yes, I will. Honestly, there are people who is not putting all these routes. I will. People who doing these three major routes, and that's it. But you can be more specific. The route table is server route table, and the resource group is route table US. Okay, the next one is this one. These are all my management networks. Route table the same. And resource group. As you can see, you can add multiple routes from different route tables. And finally, one more, yes, that is the destination of on AWS. Route table. Okay. No. And now I need the computer name of the other CSC on the pair. This is the name of the virtual machine on Azure. And the resource group of the virtual machine. The resource group is this one. Okay. And say the keep alive, remote keep alive is not configured. It's using the default values. The default value of a keep alive to check which connector is alive. The keep alive is by default checking if one can ping the other via the internal gateway. But we can do something more smart to validate the entire path to the internet is working, because this connector can answer internally, but maybe externally there is no connection. Then you can configure a remote keep alive. I will use this IP as remote keep alive. Then the connector will validate that can ping this IP internally. Then when this connector is active, this connector passive via the internal gateway will go to ping here. Then it's validating, this connector is validating that this one, the full path is working. Then this B will check A has full connectivity, internal and external. Then you need to go to, you need to put a trusted IP or something. In my case, it's a layer 3 switch that it should be always open or nothing works on my network. Then the keep alive is this one. Let me copy from here. Going back. Do you want to enable remote keep alive? Yes. And I will put this one. Okay. And now was validating the route, was taking, we have four routes under control. The other machine is that one, exists, the remote keep alive. Do you want to apply changes? Yes. And this will create a JSON file. Again, this is well DevOps oriented. As I said, I will keep this JSON file in a safe place, because via this JSON file, I'm going to configure the other in high availability. Then let's come here, Go to high availability configuration, enable purchase, and paste. Okay. Now high availability is enabled on the pair. This is the configuration that we need to do. The last thing I need to do on this connector is to refresh the peers JSON file. Then I need to go to 5 and number 2 now, and I will use the URL method. I have the URL of the bucket. Do you want to change the URL? No. Do you want to refresh the list? Yes. You can review the list here when you do manually, and it's telling you how many private apps behind each connector are. Do you want to apply values? Yes. Now it's creating the private apps on the passive CSC. It's adding the peers and it's creating the security groups. Done. This is all the configuration. Now more high availability configuration is created, and that's it. It's quite simple to do. My next step is to test if I can reach we tested we can reach this. We can see the statuses, and let's take a look of the logs, for example. If I go to gray log, you can see the PriCPA 1, and now I can see the logs of number 2. And let's go to there are logs for others as well. To this one. The query. And these are the logs of system logs. All the logs are target MHV CSC, and the system logs are info alert up down error. Okay, but if you put source only, you will see everything: the traffic logs and um, the system logs too, because there is a lot of traffic, some traffic here. As you can see, there is destinations to the DNS, some internal communications that are doing the Linux agent. You will see a lot of traffic generated by the Linux agent. This Linux agent is installed on the machine. This is a requirement for virtual machines, Linux virtual machines on Azure, and this allows you to communicate to the machine, change password, and so on. Then now in our next step, after the configuration done, we can see some statuses. Let's go to number 1. If I go to show CSC node configuration status, I will see the statuses of the machine here, and we will see the information, general information of the node, the interfaces, the IPs, externals and internals, the public IPs, the service and the PriCPA public IP, the ACCMation statuses, the logs is reachable and the traffic logs are enabled. And finally, high availability information that, well, is active. And the route to PriCPA, the next hop is 10.224 of VM this CSC. Show which CSC is active. And the route tables, you have configure the public, the IP in use is 204, and if the remote keep alive is alive. Yeah, if the machine can ping the remote keep alive, that we have to validate the full path of PriCPA. Now let's go to number 2, and in case the node number 2, again we'll have the general information, the public IPs, the DNS, ACCA mentioned, but in this case, high availability is active. The net hop is number 4, and it's saying the other CSC on the pair. This is not the active, the other is the active. Then going back to the active, you have here visibility of, if you want to see all peer statuses, it will tell you which nodes are active and which are not. In this case, I think we have 3 that are not reachable, that are this local, that is not refresh, and the G cloud is not refresh, not reachable. And we have here the AWS. On AWS, this is the local on our VMware infrastructure. This is not reachable because it's turned off, and this is another data center we have. If you want to see the information in particular to one particular node, show peer status, select the peer, and you will get the full list of peers. If I want to see the communication to this peer, you can see here the information sent, how is the status, and also you can see on the peer which networks the peer has behind and the rules apply, and you can check, okay, I can access this peer from this machine to this destination. Then you have visibility of all private apps behind this peer. The connector will provide you all the visibility you need. Well, next step, we have here this machine behind this machine, the 10235, and this machine, this server here. And we will run a test. This machine here is running high performance server, and we will run a test as high performance client. Okay. And meanwhile, let's see 3 show interface traffic on the active CSC. We can see in real time the traffic on the interface. Then let's start the test. I will run the test for a few, let's say for 30 seconds. And now if I go to the connector, you will see that the connector is near 1 gig here. The output in this interface, depending on the interface you select, you have here is incoming about 1 gig, and it's near 1 gig on the uh, PriCPA internal logical interface. Well, this is the end of the test. As you can see, it was capable to run 890 seconds test. If I run for 10 seconds, let me do it again. The performance is near 1 gig. And remember, the test is running between AWS and Azure. We always have 1 gig performance available. Well, let me go to my script. I did HEA, and then, well, we can test. Uh, we can test high availability now. We're ready to test, and what we're going to do is to shut down the CSC HA1, and I need to log in again to all my other nodes. Then let me go to my console here. Let me back to let's load. Let me first H1. This is the active one. I will stop this machine, and I need to wait up to the status is deallocated. Okay, it takes some time to go down. On my route table, this will change to 5 automatically. The connector will do it, and also the connector will move the floating IP from the one to the second, and I will get access again to the connectors. And I need to wait now to this stop it deallocated now. Let me put on this on here. Well, I'm receiving a lot of traffic here. Let me load system logs fresh. Okay. Okay, and I want to see the logs. Come on. Okay, not happy with this. I will do it manually. And now it's done for me. Thank you very much. Okay. Okay, on these logs, we need to see that the change of the route table and IP of PriCPA was moved from the connector 1 to the connector 2. Okay, it takes some about 90 seconds because you need to move all route tables via API, and it also need to move this IP from one connector to the other connector. Then it's not automatically, but it's what we have on cloud, right? Then let me check the PriCPA 2 here. If I go to networking, if I go to PriCPA, now as you can see, number 2 has the public IP 204. Then it was moved, the IP, the floating IP to this connector. And if I go to the route table here, and I do a refresh, let me go to refresh, okay. So you can see all the routes were changed to the connector 2, number 5, okay. Then that was done automatically. The movement of the IP is now here. All the routes are via connector B. Then let's do a test. I will try to go to the connector B. Yes, I did the configuration. Then now the connector B is the active. If I do show configuration status, the PriCPA IP was moved here, and it's saying high availability. Now it's via this connector, but the other shut it down, and the keep alive is alive. And if I back to my machine here, this is the Okay, I lost the communication via PriCPA. Then I will go back to via PriCPA to the machine behind the connector, and I will run the high performance test. Performance, and going back to the demonstration, show interface traffic. And let's do it. You can see the traffic is going to near 1 gig here. 900 megs. Brilliant. With this demonstration, we show it how easy it is to configure the connector using AWS System Manager, passing the parameters, main parameters via config user data at the moment of the installation, uh, then picking up the local configuration file and configuring the other CSC on HA, and finally doing the HA configuration that HA is capable to manage multiple routes, manage the net hop, and also moving the floating IP. Well, this is the end of this demonstration. Please, if you have any questions, contact us via our support portal. And our support portal is support maidenheadbridge.com. Okay, you can create log, you can create here you can log in and create tickets, and you can see the documentation CSC for PriCPA is here. Click on documentation, and you will have the administration guide that is explaining everything we're talking about. We're talking today about high availability configuration and all the stuff. Then you can get all the information from the administration guide. Well, thank you very much for your time. I hope you liked the video. As you can see, the CSC is extremely powerful. High availability works like a charm. Very easy to do, very easy to configure, very easy to manage the network as a code, just configuring the apps behind and who will access the apps. And that's much it. You have a very powerful private cloud, private access configuration, and extremely very competitive price. Thank you very much and have a good day.